And sometimes people also use polymers as dispersant. Okay, people also add polymers and dispersant to help the particles distribute uniformly, separate uniformly in your solvent. Polymer dispersant with molecular weight of several hundred to several thousand, and there are non-ionic polymer dispersant, PEG, polyethylene glycol, ethylene glycol, okay, 2 carbon, oxygen, repeating unit, polyethylene glycol, and PVP, polyvinyl pyrrolidine. This is the repeating unit. Okay, here non-ionic, which means when I dissolve this thing in water, I do not readily form an ion. Here, similar, I do not readily form an ion. But clearly, there are parts that are polar. What is the polar part? This guy, clearly, right? This guy is the polar part. This O, carbon, OC, is also your polar part. That's also the non-polar part. And PVA, each of it has an OH group, polyvinyl alcohol. This would help it disperse in water. Make sense? PVA. And ionic, so-called polyelectrolyte, PMMA, used quite often, polymethyacrylic acid. When I have this COOH group, when I dissolve in water, the H group would go, I would have an ion. Make sense? Or PVSA, polyvinyl sulfonic acid. This sodium, I probably have a mismatch here, but this sodium dissolve in water, it goes, and I have an anion group here. PEI, similarly. So we have non-ionic, which means I put them in water. This OH does not go readily, unlike this COOH, this acid group, acetic acid group. Dissolved in water, the acid H goes readily. Okay? And the feature solubility depends on the side chain. Like the PVA, the PMMA, they would dissolve, okay, depending on the side group. And OH or other highly polar group, they would dissolve in water. The PVA would dissolve in water. Others in organic solvent. Okay, they absorb on particle surface by van der Waals force. They may be used as binders in some cases.